So hi again, good afternoon. So this is the continuation of what we have discussed, which is on the definition of terms and some of the introduction of the triangulation. So this time, I'm going to show you some sample problems on the computation on the intervisibility of stations. So let's have here some of the things that we need to consider and why we need to have the computation on the intervisibility of stations. So when we say intervisibility of stations, the same to your laboratory exercise number 3, in which you are required to check if the station, like for one station, one control station, at least the two adjacent or at most all of the control adjacent to your stations are visible from where is the occupied point. So to make sure that during the angle observation, pag nagme-measure na tayo ng angle, is we can really identify the points. So if impossible, kung hindi talaga siya visible, you can either pwede mong ilagay sa ibang position yung point para maging visible siya, or you can apply or you can construct a tower. So this is the old method where they use the total station. But now we had, again, we have GNSS and GNSS techniques. So we use the satellites now, so no need for the, no need to consider the intervisibility of our station. Anyway, so for the measurement of angular values in a triangulation system, so station selected must be intervisible. As it says also that priority must be given to the establishment of the intervisibility between stations. That's why we need to conduct reconnaissance before we finally establish the control on the ground. So in the reconnaissance, we determine if our points are intervisible. So like for example, if you have a quadrilateral A, B, C, D. So if you are in point A, so make sure the other 3 points are visible, since you are going to measure the angle between A ABC, between angle ABC. So that's why our target is the 3 stations opposite or adjacent to your occupied station should be intervisible. If not, then you cannot observe the required horizontal angles. So it is a vital phase before, because line of sight must be clear for the measurement of the angles. Now, on the old methods in the conducting the geodetic control network, for example in the whole Philippines, so they employ this intervisibility of stations. So in cases in where the designated points on the ground is diri talaga yan nakikitaan, there is an obstruction for the line of sight, so they establish similar to this setup here, in which merong tower, and then on the top of the tower, doon sila nag-occupy mismo ng point. So in the establishment of the horizontal control network, the line of sight between the monumented station, which means yung nalagyan na ng mga monument, may be obstructed by trees, buildings, and other structures. So hindi lang yung topography mismo yung nakaka-obstruct, pwede yung mga buildings. Like for example, yung group na mismo nag-conduct sila ng control doon sa downtown ng Tacloban, which is full of buildings. So it's impossible na matatarget nila yung ibang points na walang obstruction since nasa downtown, so malaming infrastructure. So the problem may be caused by a lack of field reconnaissance. So since your activity, you only refer to the overview and hindi nyo nakikita talaga on the ground kung yung line of sight is nakakapasok ba talaga para ma-observe yung ibang point. So that is the one reason why it needs to have the ocular inspection, yung tinitingnan talaga sa ground kung visible ba yung ibang points. And relocating the stations may be time consuming. Imagine yung design mo is I think yung design mo, ilang beses mo na plot yung design, and then you already with oral networks, naka-establish na yung strength of figure, and then sobrang damong process nga ginihimo para lang para makahimo kan design. And then one of the alternative para sige maski may obstruction, then we will go with that, but we need to come up with a solution. And then one of the solution is the intervisibility of stations, and how are they going to adapt this intervisibility of stations. So we just employ the computation. I'm going to show you later. So in rugged terrain where eccentric station cannot be used, when we say eccentric station, ito yung mga station na we establish this station for the sake na yung mga imposible ma-occupayan is meron siyang magiging ibang station. Like, for example, A, B, C, D. Tapos, hindi intervisible yung A, B sa C, sa point C. So, maglalagay ka ng ibang point. Mag-a-add ka ng ibang point para lang makita yung ibang mga points. So, para siyang tinatawag itong eccentric station. Anyway, on the next topic, I'm going to discuss a scenario in which mag-establish tayo ng mga eccentric station. So towers are often built to elevate the instrument or the instrument man undertaking the observation and the target. Similar in illustration kanina. So the towers can build either at the occupied station or at the station being observed. So it could be yung kung nasaan yung instrument, and then yung nasaan yung target natin. So similar to this illustration, let's say this is point A on your quadrilateral in your station. So imagine this is the station and this point C. So pag because of the topography, like for example, may lang nakasagabal na obstruction, so you cannot directly observe point B. So what they are going to do is they construct a tower here. Parang papataasan mo niya. So if they are going to construct a tower along here, so if they have a tower along this area, so let's say this is the tower. So just imagine this is the tower. So the line of sight will be, we're able to pass through here. So hindi na siya dadaan sa magiging obstruction. So other thing also is, pwede silang maglagay ng tower along this point, and another tower along this point. So what they are going to do, sobrang visible na yung other point. So it could be mag-establish ng tower sa occupied, pwede rin namang mag-establish ng tower doon sa magiging observed, as long as magiging intervisible na yung ating mga point. Okay, so in this sense, yung concept lang ng intervisibility is i-determine natin yung points, 2 points, itong point na to and then point na to, kung talagang may obstruction. So our target is to determine the value of this one, to determine the height of this one. Kung ito yung line of sight, so ito lang yung dapat yung line of sight hanggang doon, ilan yung magiging obstruction, which means magkano to. So this is the value that we are looking for. Okay? So if this is the illustration, let's have some of the derivation, how we come up with the formula in determining the elevation of the obstruction. Again, our target is kung ano yung height ng point. Let's say this is H1. And then height din to ng isang point. Let's say this is H2. Our target is ma-determine natin yung elevation ng obstruction. This one. So ma-determine natin yung value ng elevation mismo ng line of sight at obstruction. So let's say here. So let's say meron tayong tatlong hill. And then meron tayong point. So this is the level surface. Let's say ito yung ating geoid model along this tree hill. So ito yung ating mean sea level. So this is the point A. Let's say, for example, ito yung ating point A. So let's say that is our point A. And this line here, that is the plumb line. So ito yung ating vertical line. So parang gano'n. So vertical line along that one, perpendicular to the gravity, that is perpendicular sa ating point. This is the gravity line or yung ating plumb line. So pag nandito yung isang point, so meron din siyang sariling plumb line yung ating point. So this line here in the blue where the gravity lies. Okay, that is your plumb line. So pagdating dito, magiging tangent siya or perpendicular siya sa ating sea level or yung ating geoid, or yung true shape mismo ng Earth, itong green. Okay? Okay. Let's say, ito yung point na ating na-occupy, and then ito yung ating dapat ma-observe. So, based on the, let's have here, nakikita nyo, meron ditong instrument man. So, yung line of sight ng instrument man, ito yun, kung target niyang makita yung ating station occupied, so it's impossible na makikita niya si station occupied since meron tayong ditong isang hill. So meron tayong nakikitang obstruction. So our goal is to determine ano ba yung height ng ating obstruction para we can compute kung anong height ng tower ang i-establish natin sa dito na banda or anong height ng tower ang establish natin dito para makita natin yung ating observed na station. Okay, so our goal is to determine the from here until this here. So yung ating goal is to determine the height of the line of sight at obstruction. Again, yung ating goal is to determine the height ng line of sight at obstruction. This is the obstruction. Ano yung height at mismong obstruction? So that is our goal in intervisibility of station. Para we can compute na how high is the tower that we are going to establish at this station? How high is the tower that are we going to establish along this station? Okay? So let's say ito yung line of sight. Itong line of sight mismo ng telescope ng instrument. So let's say this is the orthometric height. So take note, yung H natin is measured along our level surface. Ito yung ating geoid. So geoid to point, that is our orthometric height. So let's say yung orthometric height ng ating occupied station is H1. And then yung ating orthometric height or yung elevation mismo ng station observed, let's say ito ay H2. Okay? So this one is H2. And then we write also the plumb line. So let's, since we are going to determine the height of this one, so mag-a-assign din tayo ng plumb line sa ating obstruction. So this one, this line here, this is just the projection of the mean sea level. So just copy this one. Kung ano yung magiging form ng sea level, ito yung din magiging form dito. So just the projection. When I say projection, just a copy of this one into this station where kung saan yung ating station occupied lies. So ito yung magiging sea level. So ito yung sea level at occupied station, yung local na. And then this broken line, what do you think is this the broken line? This is since the Earth is not flat, and if we are dealing with geodetic control observation, we are dealing with the curvature of the Earth. So let's say at this distance here, from here, the curvature is just small, right? Because yung distance niya is closer pa lang sa ating instrument man. So sobrang liit lang ng correction ng curvature. But kung longer na yung ating i-observe distance, look at what happened to the curvature correction. Mas magiging exaggerated siya, mas lalaki yung ating value ng curvature correction. That's why we really need to take account the curvature correction when dealing with long distance measurement because since hindi flat. So paglalayo pa yung ating observation, mas lalaki pa yung value ng ating curvature. So this value here from the mean sea level until doon sa line of curvature. So this from this point in here, that is our combined correction due to curvature and refraction. This one here also is our combined correction and refraction to this distance. And from here is the combined correction and refraction correction for this whole distance. Okay. Another element, we have D1. D1 will be our distance from the station occupied to the obstruction. And then D2, ito yung distance from the station observed hanggang doon sa obstruction. So this is D1. And then D2 is measured from here to here. Okay, so if we add D1 and D2, so let's say that is D3. Okay. So let's focus first here in this portion. So again, so we consider the effect of the curvature and refraction correction. So let's say this is the instrument. So this is the line of sight. So what will happen? Mayroong deviation between yung line of sight natin and then this is the horizontal, yung na-measured na distance, and then yung line of sight natin. Since yung ating line of sight comes within, nagbe-bend siya because of the refraction. And then yung ating, this one here, this one is the refraction, and this one is the effect ng curvature. Right? So if we combine this one, this is equivalent to 0.065 times the square of the distance. So pag naglo-longer yung ating distance, mas lalaki yung ating curvature correction. Okay? So if this is the D1, itong D1, this is the combined, ito yung ating combined curvature and refraction correction. So this is equivalent to this one, 0.065 D1 squared. So that is equivalent to 0.065 D1 squared. Okay. Okay. So if this is 0.061 D1, since yung ating 8 over is D1 lang, what do you think is the value of this one? So if this is 0.065 D1, since lalaki siya dahil mag-a-add tayo ng distance dito, therefore, this is equivalent to 0.065 D1 plus D2. Since we consider the whole length, so similar din, 0.065, but we need to add the two distance D1 plus D2. So this is equivalent to 0.65 D1 D2. So this is the total curvature and refraction correction from this point here hanggang doon. This one is from this point lang hanggang dito. Okay? I hope that is clear. So since our target is the H, ito yung ating H. This is the main concern why we have to compute this one. This is the H is the elevation of the line of sight at obstruction. Magkano ba yung elevation ng obstruction para alam natin kung ilan ba, ano yung height ng tower na ilalagay natin para mas makita na, para dire-diretso na yung ating line of sight. Okay, so that is, we denote that one as H. So, how about this one? How are we going to determine this? So, if this is H1, pag H1 to, itong dito hanggang dito is still H1, right? And then dito hanggang dito, since we copy only this one to this, the equivalent length of this one is also equal to H1, right? Since if you observe from the illustration, this is H1. Therefore, dito hanggang dito is still equivalent to H1. Right? Hindi naman siya nag-change. And then dito, hanggang doon is H1. Okay, so if this is H1, and then this is 0.65 D1 plus D2, right? How are we going to determine this value? So this is just the difference. If this is H1, and this whole from here to here is H2, therefore, ang length nito ay equivalent to H2 minus H1. Paano siya naging H2 minus H1? Since yung from this point occupied hanggang doon sa zero elevation ay H2, then this one also is equivalent to H1. So just subtract this whole from here, the remaining will be this one. So this is H2 minus H1. Okay? Now, how are you going to determine this one? This will be known as our, we don't know this one. So let's say this is equivalent to X, right? So equivalent to X. How can we solve our H? So based on the illustration, yung ating H ay H1 lang. So H1 plus, may konti, this one is equivalent to this one, 0.065 D1 squared. If this is 0.065 D1 squared, plus itong x na we don't know the value of x, so that is the value of our h. So h now is equivalent to h1 plus this small correction, curvature, and refraction correction, which is 0.065 d1 squared plus this value of x. Then we can determine the value of the h, which is the elevation of the line of sight at obstruction. So there's no problem with this equation, but we don't know the value of x, right? So our goal now next is to determine the value of our x. Okay, so take a look of this illustration. So to solve for x, we employ the ratio and proportion. So let's see x over d1. Since nandito yung ating x, and this is equivalent to d1, right? Yung distance nito. So this is x, and this is d1. This is also set proportional to this here, this side here, and then the whole length, right? But this is d1 plus d2. If we take the ratio of the x over d1, this one here, x over d1, that is equal to this side here over d1 plus d2, itong whole na d1, d2. So how are we going to determine the value of this length here? So we already have h1 minus h2. So this is h2 minus h1. And then we already have the value of this small, this is the curvature correction between d1 plus d2, right? So if this is 0.065 d1 plus d2, and this whole here from this point hanggang dito is h2 minus h1, therefore, yung ating point dito hanggang dito is just the difference between h2 minus h1 tapos yung ating 0.065 d1 plus d2. Okay, so this is equivalent to h2 minus h1. This is h2 minus h1 minus this one, which is 0.065 d1 plus d2 squared. Over yung ating proportional distance na since bugos na hiya, this is d1 plus d2. So this is now our working equation. So to find x, we just cross multiply this one. Cross multiply d1 with the whole equation on the right side. So x is equal to, just copy nyo lang, and then multiply d1. Okay, then distribute. Pwede nyo siyang i-distribute yung d1 and then dito sa ating h2 minus h1, and then simplify the equation. So let's say x, ito muna, h2 minus h1, h2, multiply this one to here, maging h2 minus h1 over d1 plus d2 minus, since isi-separate natin sa minus 0.065 copy d1 d2 squared times d1. So you multiply this one, then you copy d1 plus d2. Okay, so this is now the value of our x. Can we simplify this further? So, pwede natin i-cancel out yung d1 and d2. The remaining will be isang d1 and d2 na. So, wala nitong squared. So, this will now become x equals h1 minus h2 minus h1 d1 over d1 plus d2 minus 0.065 d1 plus d2 times d1 over sa ating, wala na tayong over since we cancel out this one. So this is now the value of our x. So is this the final? No, we are going to substitute the one to finalize our equation. Substitute natin to doon sa ating working first equation. So isa-substitute natin itong whole equation doon sa ating pinaka-equation to determine our h, right? So substitute this one. So h equals to x minus 0.065 d1 squared. Then substitute yung x. So h1, ito na yung ating h1. So this is h1 plus x. Yung ating x is this whole value here. This is our x plus yung ating 0.065 d1 squared. Andito yung ating 0.061 d1 squared. So may pwede natin siyang i-cancel out, right? So you multiply this one, distribute lang. So what will happen? So pwede natin siyang ma-cancel out si 0.65 d1. Meron din dito, cancel out this one, cancel out this one. So pwede natin siyang ma-cancel out. And the remaining would be this one na lang. So h now is equivalent to h1 plus h2 minus h1 times d1 over d1 plus d2, or yung sum ng distance ng point A to point B minus 0.65 d1 times d2. Okay, so this is now our final formula to determine the elevation of the line of sight at a certain obstruction. Okay, so take note of this formula. Let's say this is not always H1. So the value here, it depends on kung saan nakalagay yung ating instrument, or this is the station occupied. Pag yung ating station occupied is nasa H2, then we change this one to H2, then plus yung ating equation is magiging H1 na minus H2, yung ganon, plus D1 plus D2 minus 0.065 tapos D2 D1. So depende siya kung saan yung ating station occupied. But this is our working equation. Okay, so we are going to use this one to solve for in determining the line of sight ng obstruction, and then pwede natin siyang i-employ to determine kung ilang height ng tower kung yung ating i-establish on this either station occupied or obstructed. So let's have an example para mas clear. So let's have an example here. You can find this example in the book of Laput, the blue one. So example A, Cathedral Hill with an elevation of here 1,138.253 meters is on the line between Aurora Hill and Mirador Hill. So merong yung isang Si Cathedral Hill is gitna siya ng Aurora, and then yung isa is Mirador Hill. So it is 16.08 kilometers from Aurora. So if this is our Aurora, yung distance niya, yung D1 is 16.608. And then from Mirador to Cathedral, yung distance niya from Mirador to Cathedral is 11.878 kilometers. So the elevation of Aurora, so yung elevation ng Aurora is 1136.264, and then yung elevation ng isang point is 152.428, so which means yung elevation ng second point. So if the line of sight o generating from Aurora, so this is say, ito yung ating Aurora, dito yung ating station occupied since nagsimula dito yung ating line of sight. So we are going to determine whether yung ating Mirador is nakikita ba siya from Aurora. So we are not yet quite sure kung nakikita siya or hindi. That's why we need to compute the value of H. Kung talagang walang obstruction or kung mayroong obstruction. So, and then number 2, we need to determine the height of identical tower which can be constructed at Aurora and Mirador Hill at the line of sight that would clear a Cathedral Hill by 3 meters. So, anong height ng tower? When we say identical, kung 10 meters yung tower na ilalagay sa Aurora, then 10 meters din yung tower na ilalagay natin sa Mirador Hill. So, anong height ng tower? So, the height of the tower which could be constructed at Aurora. So, depende sa question. Okay, let's start with number 1. The number 1 question is to determine if naka-obstruct ba yung ating Cathedral Hill in between Station Aurora and Mirador Hill. And how are we going to do that? We are going to employ our equation. So let's say H equals to H1. Pag nag-positive 2 yung ating H, which means talagang may obstruction. Okay? So based on the illustration, so this is Aurora, ito yung ating Mirador, and this is our Cathedral here, Hill. So ito yung ating line of sight, this one. And then yung distance from Aurora to the Cathedral, which is equivalent to 16. And then ng distance ng Cathedral to Mirador, which is 11.878. So since given naman yung ating lahat ng given yung lahat, we have the value of H1, which is equivalent to 1,136.264 meter. And then yung ating H2, which is equivalent to 1,152.428 meters. And then given yung ating D1, which is 16,608 or 16.608 kilometer. Then ano yung ating D2 ay 11.878 kilometer. So we have D1, we have H1, we have H2, then direct substitution na. Then all of the values, isa-substitute natin siya sa ating formula, and then we can compute H1, which is equivalent to 1,132.865 meters. So what is 132.865 meters? That is only, this is the line of sight of the obstruction. So from this point here, kung saan nakatouch yung ating obstruction, hanggang doon sa main sea level, this is equivalent to 1,132.865 meter. Right? So how can we quantify kung nagpo-obstruct siya or hindi? So it depends sa elevation ng Cathedral Hill. So from yung elevation ng Cathedral Hill, from the problem, the elevation ng cathedral is equivalent to 1,138.253 meters. So, andyan sa illustration. So this is the elevation of the cathedral. Now, if you compare the elevation of the cathedral hill and the computed elevation of the line of sight, mas greater yung elevation ng cathedral hill. Ibig sabihin, mas mataas yung pinaka-point ng obstruction. So if you are going to, so which means, naka-obstruct talaga yung ating cathedral hill sa line of sight ng Aurora to Mirador. So if you compare 138 to 132, almost 5 meters. So if you take the difference between one, take the difference, that is yung DE. Take note yung ating DE. In the illustration, where is the DE? DE is this one. Yung amount ng naka-obstruct. Gano ba yung height yung naka-obstruct? So this is from DE. So if we are going to subtract this one, H, from this H, so the remaining value is this one, itong height. So this is now our DE. So DE is equivalent to negative 5.388 meters. So ibig sabihin yung negative is that naka-obstruct talaga yung line of sight. Okay, so hindi mo makikita yung Mirador Hill from Aurora because merong obstruction na 5.388 hanggang doon sa point ng Cathedral Hill. So, okay, this is Cathedral Hill. Ito yung ating line of sight. So, meron ditong 5.388 na distance na naka-obstruct. So, let's say meron ditong points sa Cathedral Hill. Okay? So this is the amount of obstruction, yung 5.388 meters. Paano nag-positive yan? Which means, kung nag-positive yan, hindi yan naka-obstruct sa ating line of sight. Okay? Let's move to, so negative sign means that the line of sight fails to clear Cathedral here. Therefore, Mirador here is not visible around Aurora Hill. Okay? Let's move to number 2. What would be the possible identical tower which could be constructed at either Aurora and Mirador Hill, since dalawang identical tower, so that the line of sight would clear the Cathedral Hill by 3 meters. So the situation is, gusto nilang mag-construct ng magkasing haba na tower between Aurora and Mirador Hill. Tapos mayroon pa siyang clearance na 3 meters. If this is the top of the cathedral here, gusto pa nila ng 3 meters na allowance para if this is pag nandito yung instrument, nakikita niya yung identical tower doon sa kabilang station. So, the question is, how are we going to determine the value of this? Gano'ng kataas yung ating tower na i-establish between points? All we have to do is just to employ the formulas that we have. So, take note, yung ating, in this situation, we let H1, since yung ating H1 ay the same kay H2, right? So, since identical tower, which means also yung ating H dito is, this is the line of sight, since ito na yung ating bagong line of sight, that is equivalent to H. So, H is, how are we going to identify H? H, when the illustration, this is just equivalent to DE, right? This is DE plus yung ating given na clearance, which is 3. So this H is equivalent to DE plus C. Right? Yung ating required na clearance na 3 meters. Therefore, if H1, since what is H is also equivalent to H1 and then equivalent to H2. Therefore, we can now solve H1. So H1 is equivalent to 8.388 meters. And then H2 is also 3.88 meters. So this is the required height of the identical towers at Aurora and the Mirador Hill so that yung line of sight natin, maka-clear tayo ng 3 meters na clearance. So you just add the length ng obstruction and then yung ating required na clearance. Okay, we have number 2. For number 3, ano yung what if yung isang point lang yung lalagyan ng tower, hindi na maglalagay ng tower doon sa observed point. So the height of the tower could be constructed on Aurora Hill so that the line of sight would clear ground at the Cathedral Hill by 3 meters if no tower to be constructed at Mirador Hill. So let's say, for example, yung ating instrument is, we transfer our instrument at Mirador Hill. And then, required natin maglagay ng tower doon sa ating Aurora Hill. So what we are going to do is just to employ ratio and proportion. So kanina, the same man pag-compute natin na curvature and refraction, that is the same proportion na i-employ natin sa situation na to. So let's say H1. If this is our H1, right? Ano yung cover na distance niya? If this is the whole H1, kina-cover niya yung D1 and then this also. So this is D1 plus D2. And then we have another triangle. This is the value here, which is C plus DE, right? Ito yung ating C plus DE. And then this is our 11.878. So this is equivalent to C plus DE over 11.878 na D2. So we can determine the value of H1, right? So substitute lang ng ating, since may value na tayo ng C, may value tayo ng DE, may value tayo ng D2, D1, meron tayong value. This is D2. So direct substitution, we have 5.38. Do not copy the sign of the DE kanina, which is negative 5.388. Those negative is just indication kung naka-obstruct ba siya or hindi. Okay? So take 5.388 over 11, then substitute. Then the height of the tower to be constructed at Aurora, kung naka-observe tayo kay Mirador, is equivalent to 20.116 meters. Okay? So what if we interchange? But what if yung ating line of sight started at Aurora, then magko-construct tayo ng tower doon sa Mirador? So let's have here another example. So another, same to that. What if dito tayo mag-start sa Aurora and then magko-construct tayo ng tower dito? Similar din, we have 3 meters na clearance, right? So what would be the height of the tower na ilalagay natin doon sa Mirador? The same din, the value ng ratio and proportion. So let's use this H2, proportion ng H2 over sa whole length. This is H2 over D1 plus D2. Tapos, itong buong distance to, this is 3 plus 5, which is C plus DE. That is C plus DE over doon sa, so this is the triangle, right? This is triangle hanggang doon. So this is D1. So substitute. Then substitute the values. Same. 3, 5, and 8, then 11 plus 16, 02. Substitute lang yung given. And then the height of the tower that can be constructed on Mirador para mag-clear siya from Aurora with a clearance of 3 meters is equivalent to 14.387 meters. So ito yung tower na i-establish natin doon sa ating Mirador Hill. Okay, I think I hope you can follow me. So that will be the end of our presentation for the intervisibility of station. So don't forget our formula in determining the line of sight. This is stage 1. This is equivalent to our station occupied kung saan ka nag-occupied. Then this H2 minus H1 times D1 all over D1 plus D2 minus 0.065 D1 and D2. So just take note of the given formula. So we can now determine the value of the line of sight and the height of the towers to be constructed between stations. Okay, so next to this presentation, I'm going to give you another problem which is related to reduction to sea level length. So see you on the part 3 of this presentation.